All right, so let's review a little bit because we didn't have any graphing to deal with, and then I'll go over the homework problems as well. So remember, we have this, a times b, and b is raised to x. B is raised to a letter. And we have to remember that 0, comma a is the y-intercept, and then this is going to be your growth. Now, again, we're doing this just as survival, so yesterday I showed how 3 points were established, and then I showed you a little bit of how you could just do it based on 2 points. All right, so I'm going to do this first problem. We'll do this one first. Things that we need to put in place. Along the x-axis is something called the asymptote. That's what we can't cross. Now, that asymptote will move, but not in Algebra 1. In other math classes, it will move, but for right now. So when we take a look at this, we have to say, okay, if I look at my equation, my y-intercept is going to be 0, comma a. So my a value on this one is 4. So 0, 4. 1, 2, 3, 4. Okay. So what's that? Oh. So when we work this kind of problem, let's find a second point. Go back to my yellow to stay consistent. Let's find a second point. So what I'm going to do is do a little t-table here. So what value should I plug in to get a second point? What do you think would be good? If I plug another, I already have 0, comma 4. So what's another x value I should pick to plug in? 1, okay. So if I plug 1 in, I'm going to get 4 times 1/2 to the first. 1/2 to the first is just 1/2. So 4 times half is 2. So I get 1, comma 2. Okay. So this particular function, if we continued it a little bit, we could plot another point. If I plotted -1 and plugged it in, I'd get 4 times 1/2 times -1. What should I do with the half with it raised to the -1? What should I do with this half if it's raised to a -1? Last chapter, anybody?
It's 0 or 1.
So what should I do with this? So what should I do right here? And it's not negative. What does that negative exponent do to the fraction? Flips it. So I get 2 over 1. 2 over 1 is the same thing as 2. 2 times 4 is 8. So this gives me the point -1, 8. Now notice, and I said we could do this with 2 points, but I just wanted to have that third point in there. Does this look like it kind of went different than what we had plotted yesterday? Yesterday we had this kind of flip over. It was going the opposite way. Okay? So that, what made, so, what do I want to do? So let's say I had y equals 4 times 2 raised to the x. 4 times 2 to the x, you're still going to get this. This is what the original function would have looked like that we had done yesterday. Okay, so the red is the original from yesterday. The black is what just happened. And this is the equation I just graphed. So notice this current equation is red. What's the difference between that 4 times 2 raised to the x and the one that we just graphed that's circled in yellow? What's different? It's going to negative infinity. I like it. Okay. But if you look at just the equation itself, so let's take a look at this and this. Now, we have one that's y equals and one that's f at x, but that's okay. What's the big difference between these two, though? What's the big difference between the equations? What do you think made the graph kind of do a pirouette around the y-axis? That means spun around it. Take a look at the two things I have highlighted in the pinkish purple. One is 4 times 2 to the x, and one is 4 times half to the x. What's the difference? What value, A or B? B. Notice the B value is a fraction between 0 and 1. Okay? Because there's a fraction, that means it changes the direction. So let's think about this. I said the domain for all of these is going to be negative to positive infinity. Agree? The range for both of these is still going to be 0 to infinity because it's starting at the x-axis and going up. Okay, so the domain and range, whether it has pirouetted or flipped around the y-axis or not, the main changer of that. So what do you think might happen with this equation? Does this equation look a little bit different, and what do you think makes it different? Thoughts? It has a negative out front. Okay, so I can squeeze a value in there. Let's put a 1 right there. So what would my y-intercept of this one be if that was a negative 1? 0, negative 1. So 0a, right? So take a look at where this is crossing. So what do you notice about that dot down on bottom? It's negative. It's on the other side of the green highlighted line, right? The asymptote. Okay, so let's pick another value. Let's see. I could pick 1. If I plug 1 in, I get negative 1 times half raised to the first. So that's negative 1 times half. Half of negative 1 is negative half. So 1 negative half is here. Okay. If I plugged negative 1 in, it's going to flip it over. So this is going to give me a negative 2. So notice what that graph looks like. It flipped it over the asymptote. Okay, so I could plug in these points just traditionally. Okay, so that's a little bit different to think about, but let's talk about this. So we have y equals a times b raised to the x. So the y-intercept of this is going to be 0, comma a. And if everything just stays as is in that graph, let's say our b is a number bigger than 1, then the graph of this particular one is going to look like this. Okay? Now, if I did this, and let's say b is a number between zero and 1, so a fraction or decimal, then the graph is going to do this. But then if we had this kind of graph, and b is bigger than 1, then this graph is going to do this. And then last case, let's say I had y is equal to negative a times b raised to the x, and b is between 0 and 1. That's going to flip over the x, flip over the y. So then that's going to look like this. Okay, so just kind of some thoughts. Realize if you have negative numbers, whether it's a negative a, or if the exponent's negative, or if the b value is a small fraction, there are a few things that take place. Now, I want to go back. No, I'm not going to do that. All right, so let's go back and take a look at the homework problems I gave you. So problem number 1, we had y equals 9 to the x. So this is not exponential. Okay? Reason it's not exponential is the letter is not an exponent. Number 2, we have y equals 2 times 3 raised to the x. This is exponential because our x value is an exponent. And then problem number 3, this is also exponential because my exponent is the letter. It's a variable. Then I asked you to do number 6, and it said y equals 2 times 4 raised to the x, and we want to know what happens when x is equal to negative 2. Well, I'm going to take this negative 2, and I'm going to replace it here. Okay, negative exponent with this 4 is going to do what with the 4? It's going to move it where? To the bottom, so I get 4 squared. Okay, 4 squared is 4 times 4, which is 16. So I get 1/8. So that would mean that would yield me the point negative 2 comma 1/8. Okay, so again, this is just from the homework from last night. And then number 7 homework, they said, hey, we have f at x is equal to negative 3 times 5 raised to the x. We want to know what happens when x is equal to 3. So what I'm going to do is I'm going to put this 3 right here. So I get 3 times 5 raised to the third, which is 5 to the third is 5 times 5 is 25 times another 5 is 125. So that's going to give me negative 375. Okay? So we're still on our quest of not having a whole lot of homework. Why don't we have you guys try page 197, 8, 9, and 10. Well, just trying to.
Didn't we just do 8?
We did 1, 2, 3, 6, 7. Oh, maybe I did 8 on the notes. I don't know.
Yeah.